Okay, so let's dive right into this explainer on building a truly professional grade video recorder. We're going to uncover the architecture piece by piece. So let's start with a really common experience, one that actually highlights a major technical challenge. You know the feeling. You download that meeting recording and you're just expecting one single polished video file. This is the heart of the user expectation gap. Because how you package an idea, how you deliver the product, matters almost as much as the idea itself. And here's that gap in plain sight. On the left, this is what you often get: a messy crime scene, just a confusing zip file full of separate videos that devalues the whole thing. But on the right, that's what you want: the clean, engineered result that just plays. So why does this even happen? Let's take a look at the main suspect here, the simplest but also the most flawed way of recording. It's called packet dumping. And it sounds straightforward, right? A server just saves every incoming video stream directly to its own file. But that's the root of the problem. It completely ignores what the user will have to deal with later. It's a solution that's easy for the server, not easy for the user. The process is just brutally simple. A stream comes in from user 1, and bam, it's saved to user1.mp4. Another one from user 2 goes into user2.mp4. There's no mixing, no syncing, no intelligence at all. It's just a raw data dump. And that's the million-dollar question, isn't it? If it's so simple, what's the big deal? Well, the problem is that simplicity for the server creates a massive headache for the user. And that's the core issue we need to solve. Because that raw output forces you, the user, to become the video editor. And you didn't sign up for that. You're just trying to watch a meeting, not produce a feature film. You expect an engineered recording, not a folder full of raw materials. Okay, before we dive into the real solution, a quick note. We're aiming to help Lalit Official hit its very first community milestone, 50 subscribers. So if you find this explainer valuable, a quick subscribe helps us get there, and it unlocks that live session for everyone. Thanks for the support. Okay, now let's get back to engineering the proper solution. All right, back to it. Let's reveal the core of the solution, GStreamer. Think of it as a powerful pipeline-based multimedia framework that's going to act as our very own media factory. So imagine a modular system where media just flows from one processing station to the next. We're not just dumping files anymore. We are building an assembly line to transform raw, messy streams into a single, polished, finished product. And this shows that factory model perfectly. Multiple streams come in, they get processed in parallel through specialized stages like decoding and scaling, and then they're merged together by the compositor onto a single canvas. From there, that single synchronized stream is encoded and saved. It's beautiful. Of course, every factory needs a manager, and that's where a high-level language like Python comes in. It's going to act as the orchestration brain for our whole GStreamer pipeline. Now, this separation of tasks is a really critical architectural insight. GStreamer is the muscle. It handles all the heavy lifting with the pixels. Python, on the other hand, is the brain. It doesn't touch the raw video data. It just acts as the director, telling all the GStreamer elements where to position each video on the canvas. And look, this isn't just a theoretical idea, it's totally practical. As this person on Stack Overflow points out, you can actually change layout properties like position and size while the pipeline is running and actively recording. It's designed to be dynamic. So here's how Python works as that external controller. When a user joins or leaves, Python instantly recalculates the grid and then just updates the properties, the X position, Y position, width, and height on the GStreamer compositor's pads. It all happens on the fly, and the layout just adapts in real time without skipping a beat. Okay, this whole process, decoding, scaling, compositing, and then re-encoding multiple video streams at once, it's incredibly intensive for a computer's CPU. To make this work at any kind of scale, we have to bring in our secret weapon, the GPU. I mean, this visualization tells the entire story. If you try to do the encoding in software on the CPU, you will completely max out the system. It's a massive performance bottleneck. But the second you offload that same task to dedicated hardware, like NVIDIA's NVENC, the CPU load just plummets. The whole system is freed up. The trade-off here is crystal clear. For real-time applications like a live recorder, the high CPU load and higher latency from software encoding are just unacceptable. Hardware acceleration is absolutely non-negotiable if you want to maintain system stability and a responsive experience. So let's bring it all together and really distill the core architectural lesson we've learned through all this. We've seen two totally different philosophies. One just saves files and pushes all the complexity onto the user. The other actually engineers a complete media solution to deliver a professional, polished result. And it's that key partnership, Python as the brain, GStreamer as the muscle, that makes it all work. And that right there is the ultimate takeaway. It's a shift in mindset. You're not just a file saver anymore. You're an engine builder. And that's what separates a basic script from a robust, scalable, and production-ready system. If you found this technical deep dive valuable, the best way to support the channel is to share, like, and subscribe. Let's hit that 50 subscriber goal before February 28th, 2026, and we'll see you at the live introduction session. Thanks for watching.